Assalamu alaikum guys. Today in this important video lecture I will discuss the most often asked question in civil engineering. And this topic is very useful for those students which are working on construction site, or if you are working as a site engineer on construction, so it can help you. And also it's important for non-civil engineering people because they don't know about the lapping length, rules for lapping length, that where we can provide the lapping length and what should be the length of lapping length for beam, column, etc. So today I will give you the basic rules for lapping length. So let's start guys. If this video is helpful for you, so don't forget to like this video. Guys, the first one, as you know, we have compression member in RCC structure, that is column. Many students, they are asking, sir, what is the formula for lapping length, especially for RCC column? So guys, RCC column is compression member. So lapping length for compression member is 40D. What? 40D. Where D is dia of steel bar which you are using in longitudinal bars. As you can see guys, this is compression member, and compression member, this is longitudinal bar. So for example, I need to provide lapping length here. Okay, so guys, here you can provide lapping length with the formula of here at this point. Okay, not the point, because this is, I'm just discussing the lapping length formula. Okay, so guys, this is called lapping, compression lapping. Okay, so you can get the length of this lapping with the help of 40D, where 40 multiply dia. For example, if the dia is 12 millimeter, okay, so 40 multiply 12, so this should be the distance of lapping in compression member, where D is dia of steel bar, longitudinal dia, okay, or that steel bar dia which you are using in compression member. Okay, this is the formula for compression member. The second one is guys, lap length for tension member. So what is tension member? Is, you know guys, tension member is beam, slab. Okay, so for that you can use what, for which one formula? 50D. What? 50D, minimum 50D, and minimum 40D for compression, means for column. Guys, you can see this is beam. Okay, so especially for beam or slab, so here the length of the lapping should be minimum. This is lapping guys. Okay, so this, okay, so this length we can get with 50D, minimum 50D, where D is dia of steel bar. For example, this is, for example, 16 mm or 12 mm, etc. Okay, so here you can get the length 50 multiply. So if this is 16 mm dia or 12 mm dia, for example, if this is 16, so 50 multiply 16, then you will get the tension member lapping length from the formula of 50D. Right? Now guys, what are the basic rules? Remember guys, for compression member and also for lapping, okay, so I'm talking about lapping. So if the lapping is in compression member or if in tension member, so more than 36 mm dia steel rebar, the lapping is not allowed. Means lapping is not allowed if the dia of steel and compression or in tension member is more than 36 millimeter. So the lapping is not allowed. Keep in your mind this point. This is also often asked question in interview, that to which dia we can provide lapping length. So you can answer that more than 36 or 36 mm dia of steel rebar, the lapping is not allowed. Okay, so guys, this knowledge, okay, are the reference of this knowledge is what? This one, IS 1392-2003, and the clause number 6.2.6. If you can't see, so I will write here IS 1392-2003 and clause number 6.2.6. Right? Now guys, the other one, for lapping take lesser dia of steel bar. For example, if this die of steel bar is, for example, this die of steel bar is 12 mm, right? And I am overlapping the other steel bar here. As you can see, guys, here we have the lapping. F in compression member or F in tension. So the lapping length, for example, we are using we are using here 50D. So here, which one dia we will take? So this dia is, guys, 16 mm and this dia is 20 mm. So from IS code, for lapping take lesser die of steel bar. So we have two die of steel bars here. One is 16 mm, the other one is 12 mm. Now I need to keep or to take the distance of lapping. So here the D should be what? So 50 multiply lesser dia. So lesser dia is not 16 but lesser is 12 mm. So multiply 12, then we can get the length of this lapping, right? This is very useful. If there is compression, so also for compression you will take the lesser dia. So if we have two diameters and two diameters of steel rebar, we are overlap with each other. So there, to get the lapping length, so the D in which we are using in formula 50D and also 40D, 50D in a beam and tension and compression 40D. So there the D should be select the lesser dia, not the higher dia, okay? The other one is, guys, lapping length should not be provided at the same point. This is very useful. For example, guys, this is column. So here we need to provide lapping, for example, here, okay? So guys, you can see this is lapping. This is lapping. So the other lapping should not be provided at the same point also, like this. Not, guys, this is wrong. But the lapping length should be provided at the distance of 1.3 times of the lapping distance. For example, if, guys, for example, if this is 60 centimeter, for example, if the lapping is 60 centimeter, this is just the example. So the other lapping should be provided with 60 multiply 1.3 time. 1.3 time, okay? So from this you can get any value. So after this, from this center, okay, from this center, from this point, then the lapping should be provided here, guys, like this. This is lapping length. So here, as you can see, this is lapping length and the other lapping is up or and down, but the distance of 1.3 times. Okay, so lapping length should not be provided at the same point. So where we can provide, so place with 1.3 times of lapping distance. For example, so this is 60 centimeter, so the other should not be provided opposite to this. So it should be down or up, but with the distance of 1.3 times. 60 multiply 1.3. So after, from this center, you can keep the to other center. So this distance should be what? For example, we can get from this value, we can get about, for example, 75 centimeter. So 75 centimeter. So after 75 centimeter, we will keep the distance between two lapping. Then it will make a good joint and a good bond between concrete and also steel bars. So guys, this is the basic rules for lapping length. So I hope this video can help you if you are working on construction site, if you are non-civil engineering, or if you are studying. So I hope this can help you. So guys, if you have any question about this video, so you can comment. I will try to reply your answer. Thanks for watching. See you in next video. Goodbye.